Okay. Section, oh, I didn't change my section number. Give me a second. You know, I do a lot of these all in the same day, hence the exact same clothing, because, work on the weekends for you. I know, right? Do you work on the weekends for me? No. All right, so I must love you more. That's what this means. Now you know the secret. Okay, so working on the weekends for you. Hey, look, can you see the word section? All right, there you go. So section 3.5 is more one you really need to look in your book for, because there are some things you need to make sure you copy down out of your book into your notes, not necessarily on the lovely definitions page, which is what I implied when I highlighted it, but definitely in your notes. They need to be copied down somewhere. So on page 105, down at the bottom, you see a lovely little chart. See? There it is, that chart. That's what I'm talking about. Okay, lovely little chart. It gives the number of sides of a polygon and then what their special names are. Now, polygons only get names from the number of sides. So when we talk about triangles, there are like 7 different kinds of triangles we could be talking about, right? Well, the same thing goes with quadrilaterals. When we talk about quadrilaterals, all that word really means is that it has 4 sides. That's it. So it could be a square, could be a rectangle, could be a rhombus, could be a trapezoid. Lots of different quadrilaterals in the family. Just saying. Could be a parallelogram. You never know what you're going to get. So don't jump to the conclusion of what one of those things may or may not be when I say the word quadrilateral. You got to stick with something kind of set. Okay, not necessarily any of those things. All right, so quadrilateral. 5 is a pentagon, 6 is a hexagon, 7 is a heptagon or a septagon. We had that conversation before. I know it's Roman and whatever else had the gods. Greek, Roman and Greek, right? I think so, Roman and Greek. So it depends on which one you're coming from. One of them is more Roman, the other one is more Greek, but they both mean the same thing and they're both widely accepted. If you don't believe that septagon would be accepted, then you don't believe in September, which is what month we're in right now. Just saying. There you go. So, octagon is 8 sides. I knew, October. Just saying. Nineagon is 9 sides. Should be September, right? No, they messed up our calendar. Got a video for that later. When you're a little older. Sorry. Nonagon is 9 sides, and decagon is 10 sides, and then your book quits and it goes this 11agon thing, which is called an onagon. O-N-O, onagon. O-N-O-A-G-O-N, onagon. 12 is important no matter what they say. It's called a dodecagon. That's something my mom is liable to say, something you are liable to hear a lot. Dodecagon. Just throwing it out there so that you know. Okay. That takes care of the information that you need to copy off of that page. Turn page. So we can talk about the other information you need to copy. At the very top, they have 3 separate quadrilaterals. Some of them are equilateral, some of them are equiangular, and some of them are both. You need to know the difference. So we did this whole thing with triangles where we talked about equiangular meant that it had to be equilateral. Well, that's because it is a triangle. That is true for triangles. It is not true for every other kind of polygon. It's only true for triangles because in triangles you cannot have any diagonals. So that leads us to a discussion about diagonals. Aren't you happy about this? So when we talk about diagonals, what we're talking about is it has to join 2 non-collinear vertices. So it can't be side by side. This is A and B are collinear, so we can't have a diagonal that connects them. A and C are collinear, so we can't have a diagonal that connects them. My diagonal from A would be from A to D, because that's the only non-collinear point in this. There are exactly two diagonals in a quadrilateral. Doesn't matter what kind of quadrilateral it is, it's going to have exactly two diagonals. In a pentagon, from each vertex, we can draw two diagonals. So from G, I can get a diagonal going to E or a diagonal going to I. We can't count GH because they are collinear. We can't count FG because it's collinear. It forms that polygon. But the two diagonals that come from our vertex go off to other non-collinear vertexes. Now, if you get one diagonal from each of these vertexes, we get two from each of these. 2 times how many different vertexes do we have? 5. 2 times 5. 10 possible diagonals in a polygon. See how that works? So, now, wait a second. Not 10 unique possible diagonals. The reason is, when I come over to I to draw my diagonals, I've already got this one drawn in. So when we talk about unique possible diagonals, that changes our name some. So I have these two from there. When I get to H, I can draw 2. That's a total of 4. When I get to I, I've already got that one, so I can only draw that one. That's 5. When I get to E, they're both already in there. F both already has theirs. So there are only 5 unique diagonals in a pentagon. See how that works? 2 unique ones in a quadrilateral, but 4 total diagonals, because AD is technically different from DA. Don't ask, but I promise you it's true. So, that being said, they came up with some funky formulas for stuff like that, but you'd much rather just go ahead and draw the picture and count them up yourself. It's much more interesting than worrying about memorizing some formula you don't really need to know. Okay, that's my statement about that. Now, we do need to talk about convex and concave. Convex is what most polygons look like. It means that all of the vertices are outside of the line. Concave means it looks like there's a little cave-in spot. Hence the word concave. That's all the difference is. When we talk about polygons, we are assuming they are all convex polygons. Unless they specifically say it is concave, we assume that it is convex, which leads us to the big definition. Big definition. It's like a big question, but it's a big definition. The big definition is regular. See, it doesn't seem like it'd be that big of a deal because it's regular, hello, but regular is a huge deal when it comes to polygons. When we talk about a regular polygon, it means that all the sides have to be the same, so they're all going to be congruent, and it means that all the interior angles are congruent. So that's not a regular polygon. This is not a regular polygon. That could be, but if it is, it's a really bad drawing of one, because that one was just kind of sketched willy-nilly. The only kind of regular quadrilateral you can have is a square, because that's when all the sides are congruent and all the angles are 90 degrees. That's what makes it a regular polygon. A regular pentagon would look like the Pentagon in Washington, D.C. That's what a pentagon looks like. That's regular. All the sides are the same length, all the angles are the same angle. A regular hexagon looks kind of like it was meant to be in a honeybee comb. Regular septagon, octagon, regular octagon looks like a stop sign. Understood symbol for stop. You get the idea. We have mostly regular ones. When we build things, we usually build regular ones because it's easy on us to build regular. The only thing that we tend to gravitate towards more than squares is the pretty rectangle because it gives us more room when we're building. But other than that, that's what regular means. So they're going to use these definitions and they're going to use these words and they're going to try to trip you up a little bit in your classwork and homework, but you can do this. You got this stuff. I know you do. It's okay. It's all right. So, classwork and homework. It is located in the practice exercises on page 107. The classwork is going to be numbers 1, 16, 20, and 22. And I once again made sure that all the answers to these were in the back. Awesome me, just saying. Homework is going to be numbers 3, 18, 24, and 26. Still not a lot. You can handle this stuff. Now, today they try to trip you up a little bit and throw some algebra in there, but I think you'll be okay because you're getting really good at making those kinds of statements to solve. So I think you'll be grand. And one more section, which means come Tuesday, we'll be done with chapter 3 and you'll be ready for your review and your test.